Hello. In this video, I'm going to discuss about a particular equation by which we can approximate the total number of people getting infected by a particular disease in a particular population. So, as in the thumbnail, I've already written that's a general equation, and what does that mean, and what is the actual extent of that, and how can we actually manipulate that particular function? I'm going to discuss in this particular video. So over here, as you can see that n equals to 6.3. So that term actually means the total number of population, the total population of a particular area. This t equals to 0.5 means the total transmission rate. So T1. So from here comes the particular equation that I've already defined in the thumbnail. So T1 equals to NT. So T1 is the total number of people that are getting infected in the first year. Fine. And that actually depends on the total population and the transmission rate. So I have directly multiplied n and n times t. For the second year, the total number of people that are susceptible to get infected are obviously the people who are not infected of the population. And how does the transmission rate actually vary? The transmission rate obviously depends on the total number of people that are already infected, because they are the people who are prone to they are the people who are prone to spread this particular infection. So that particularly is directly affecting the particular population that are getting infected in the second year. Fine. So the same thing is for the third year. Fine. And over here I have defined for the first 5 years. As you can see, so the total number of people getting infected in the n plus 1th year actually depends on the total number of people already infected in the nth year. Fine. And obviously it depends upon the transmission rate also. And the number of people that are getting infected are prone to spread that infection to the ones who are not infected. And over here I've considered the population to be more or less stable, and I have also considered that the people who are getting killed and cured are not infected anymore, because the people who are already cured cannot get that infection again because the antibodies are already developed, and the people that are the people who are dying, they obviously do not fall under the category of infected. Now I'm going to explain that. I'm going to show that how the transmission rate actually is affecting the particular population's infection rate. The total number of people getting infected, how the transmission rate actually affects that. So over here, as you can see, the n equals to 6.3. It can be anything like 6.3 million people in a particular area. So over here you can see the t equals to 0. So the slider t equals to 0 means that there is no particular transmission rate. So it actually means that there is no infection at this particular moment. Now once I move the slider right, you can see it is about 0.2%. It's not 0.2%, it's 2%. Now it is 4%. Now as I keep on moving that slider on the right side, you can see that the total number of people getting infected rises. Now at a particular point, you can see that there are two spikes. So what this spike means, we call it as a bimodal distribution. So bimodal distribution actually means that there are two peaks at a particular graph, and as you can see, so as I keep on increasing that, you can see that at a particular moment it also occurs that there are no more infected people. It can mean that either the total number of people are killed or they have all recovered from the particular infection. Now this does not only depend upon the total transmission rate. It also depends on the total population. As you can see, if I keep the transmission rate constant at say 52% and I change the population, you can see as low the population is, the total number of people getting infected by the infection actually falls. That is obviously quite clear from that. But as I keep on increasing that, you can see we get this bimodal distribution again, something like the bimodal distribution again. So we can say that this particular equation actually defines the bimodal distribution and all the total number of people that are getting infected by a particular infection of a particular population. So we can see that it is actually how this equation is actually helping us to approximate the total number of people that are getting infected in a particular population with a particular transmission rate. So that is all about in this video. Thank you everyone.